Hello everyone and welcome back. So in today's video what we are gonna be doing is solving the fifth problem of educational DP contest. Now this problem is pretty much similar to the problem which we solved previously, that is Knapsack 1. And in fact the problem statements as well as the input format is kind of similar. So the only difference here is the constraints which are given, and I will talk about this later in this video. So I won't go into crazy details in this problem because I have already explained this problem properly in the previous video. So I'll assume that you guys have already watched the previous video, and if you haven't, then please pause this video and go check that video out. And I'll also request you guys to subscribe to my channel and also hit that bell icon. So let's jump into today's problem. So this is the problem which we are gonna be solving. This is Knapsack 2 and this is Knapsack 1 which we have solved earlier. So I just wanted to do little bit comparison between both of the problems. And as I told you, the problem statements are same and the difference is in the constraints which we are dealing. So n is almost same. In fact, it's same. So if you see the value of W, it goes till 10 to power 5 in the previous problem, and the time complexity for our previous code was n into W, which was 10 to power 5 into 10 to power 2, that is 10 to power 7, and our solution was getting accepted. But if we see here, W is 10 to power 9, and if we try to solve this problem using the same solution, then the time complexity will be 10 to power 9 into 10 to power 2, which is 10 to power 11, and our solution won't work. So we have to change our approach little bit, and we have to change the DP state as well, which I am going to talk about. So if you see here, the value of V here is pretty less compared to the uh, problem which I have solved earlier. So it's 10 to power 3 here, while in previous problem it was 10 to power 9. So we can build a DP state between n cross V value rather than n cross W, then all solution will work because the time complexity that way will be 10 to power 3 into 10 to power 2, that is 10 to power 5. So let's try to solve this problem, and I've taken the same example here, and let knapsack capacity be also same. So the only difference here, as I told you, it will be in DP state. So there it was n cross C plus 1, where C was the capacity and we were initializing every element as 0. But here the dimension will be n cross V, and V here represents the value, and n is kind of same, where n is the number of items. So let's see what dp of I comma v now represents. So dp of I comma v means the minimum weight that are needed to get to value v using these items. So here we are dealing with minimum weight, but in the previous problem we were dealing with maximum value, that is this. So dp of I comma j was representing maximum value. Here it is minimum weight, so that's the only difference. And if we see the base case, it's kind of same. So I comma 0 is 0, but the definition changes. Here 0 represents the capacity, but here 0 represents the value. And let's say how I comma 0 becomes 0. So why this is happening is, so how can we reach to value 0? So by reaching to value 0, we don't require any weight, so that's why it's 0. And I'm initializing each element here as infinity. Why? Because we have to find the minimum weight. Here we were making everything as 0 because we have to find maximum value here, and here we have to find minimum, so we are putting infinity here. Now the recurrence relation will be same. So if the value of each item is less than or equal to the uh, value which are there, like the total value, and then if it's less, then we have to condition either to include the item or to exclude the item. So if we include the item, then take that item's weight, and whatever the remaining value, we'll try to reach that value without the item I. So that's what is written here. And what happens if we don't include the item I at all? Then we will be remaining with same value. So that's what is written here. And if the item's weight itself is greater than the value, then there is no point of choosing that item because we can't reach to that value v. So I'll try to explain this in depth when I put the values in DP table. So this is the same thing. And so you guys must be wondering what v was here. So v was these values of this columns. And let me ask you one thing. So how can we reach the, what will be the maximum value that we can reach by using these items? So the maximum value will be uh, the total of these value, that is 4 plus 3 plus 1, that is 8. That's what is written here. So if we include all the items, so then we can reach this value 8. And I'm in starting from 0, and this represents the items like I have told you. And I am also taking item 0, and this is item 1, 2, 3, and each item has some value which is 0, 1, 3, 4, which is listed here. So let's try to fill this and see what happens. So for, well, how can we reach to value 0? So for reaching to value 0, we don't require any item or any weight. So it doesn't matter how many items we have. For reaching to value 0, we don't require any weight. So that's why I put 0 here. And I have initialized everything to infinity initially. So that's put it here. Why we have put infinity? Because if I have an item which with a 0 value, there is no way I can reach to value 1 or value 2 or till value 8, because I don't have that much value of that item. So I have just simply put infinity because it's not possible at all. Now let's see for this. I have an item with value 1. Can I reach here? So this I have already told you. So I'll go to value 1. So I can reach to value 1 by using this item. So that's what I have written here. And can I reach to value 2 using this item with value 0 and 1? No, because one, whatever combination we form here, we have the maximum value as 1. So we can't reach to 2, and we can't reach to 3 also. That's why this is infinity. And similarly, if we include all these 3 items, can we reach to 1? Yeah, we can reach by just including this item. That's what it written here. Uh, just copying the previous value, which is 1. Now, how can we reach to 3? How can we reach to 2? So if you do any combination here, 3 plus 1, which is 4, or 1 or 3, we can't reach to 2 value. That's why it's put infinity. And can we reach to 3? Yeah, we can just include this item 2 with value 3, and we can reach to uh, this value 3. So the item 3 if we include, then the value will be 3 minus 3, which is 0. And what is the weight associated with this item? That is 3. So that's what it put here. No, so the weighted 2 and that is put here. So can we reach 4? Again we can reach 4 by including both the item, that is 3 plus 1, that is 4. And how much weight these items have? This item 1 and item 2. So item 1 and item 2 has weight 2 plus 1, that is 3. So that's what it put here. And similarly, if we try to fill for 5, it's not possible because 3 plus 1 is 5, 3 plus 1 is 4. And do if we also include the item with 0, then maximum we can achieve is 4. So we can't reach to 5, and similarly we can't reach to anything like 6, 7, 8 value. So that's what it put here, infinity. And similarly you will try to solve this for item 3 with value 4, and you will have some answer. So these I told you are the ways. So we have to find the maximum value which we can reach with capacity 5. So we'll go from here and check what is the corresponding value for weight 5. So 5 has value 7, so that will be your answer finally. So we'll go from here and check for all the value, all the capacity less than 5 or equal to 5, and see what is the corresponding value. So that's the whole idea. And you can use this formula because I have gone into depth in previous problem like explaining this formula. So you can easily fill this using this formula as well. So I wanted to make this simpler, that's why I didn't like explain how we are using this formula. So if you guys have understood how we are filling this DP table, then I'll move on to the code. So let me just copy the previous solution. And in fact the input format is same, so there will be very less changes which we have to do here. So this is I think knapsack 1. Yeah, I'll just copy it and I will try to solve it here. So let me just open custom test and let me just zoom it here. Okay, so this is your previous solution and this is not gonna work. Input, as I have told you, is same, so we don't have to worry about this as well. So this n cross c plus 1 we are not doing, but before that we have to do something else also, that is we have to include item with 0 comma 0 value, means item 0 with value 0 which is not present here. So I just have to append item 0 with weight 0 and value 0. So that's what I'm going to do here. So weight dot append item 0 and value dot append 0. So we'll have the first item as well here, 0 0 0. And now we have to initialize everything as infinity and also change the dimension. So now the dimension is n cross v or v max. So this will be max value, and I have told you max value will be the sum of all the values which we have, which is in this case calculating the sum of these value 4 plus 3 plus 1. And I can simply do like this. So this is there, and this I will go till this value. Let me just zoom in. This is max value, and this will be n plus 1 because we are going from 0 and These are the maximum value which I was talking about, which is till 8. So it will be till from 0 to 4 and from 0 to 8. So that's what is written here. This is 8 and this is till 4. Now the second thing is we have to initialize the column 0 with all the value as 0. So before that we have to make everything as infinity, and let me put infinity value as something big like 10 to power 10, and we are filling everything as infinity, and we'll change this loop for I in. So we have to fill all these value till n, and this will be column 0 and this will be I initialize as 0, and these all will already be filled with infinity as I have filled it here. Now this is same. Now we are not dealing with capacity, we are dealing with max value. So this will be max value plus 1, and I am starting from 1 because I have already filled these value. I am starting from here, and this will be V, and this will be Vi. If Vi is less than V, then we'll put these value. So if we include the item Vi, then we'll put its weight plus we'll find the remaining value, which is V minus Vi. And if we don't include this item I, what is the best we can do? That is V dp of I minus 1 and V. And if the weight of item is larger, then we can't reach to this position, this value V. So this will be similar to this, and this is the same formula which is written here. Now if this is done, we have to do one more step here. Remember I told you in that we have to iterate over last row and find the corresponding value for capacity 5. So for that I'll just put result is equal to 0, and I will loop for I in till maximum value, and if dp of also last row will be n, and this will be from I. So this should be less than capacity. If this is possible, then result will be what? If we reach equal to C, then result will be this I value. So that's what I'm putting here, and in the end we should just print the result. Okay, so let me just see the solution. I think this should work. So if I run, I should get the value as 7, but I'm not getting that. Why? Because I'm not using minimum here. Let's try to run it again. Okay, then I think I'm doing something wrong here. So this is making everything as 0. So this is actually opposite. This should be like this, and then if we try to run, Okay, so these value will be changed. I is changing. We are putting 0, and this is wait. I am starting from 1 to match well plus 1. We will check in I comma v I minus 1. So let's try to print dpa as well, dp of n, and see what we are getting. So somehow this value is not getting stored here. Let's see what's happening. So the last row is not getting filled. Why? Because we are not going till n plus 1, and I think if I print here now, it should give answer 7. Yeah, so this is the answer. Let me just quickly run it for all test case. I think this should be accepted. Yeah, so the answer is accepted. That's all from my side. If you like my video, please subscribe and I'll see you in the next video. Thanks everyone.